In this video, I'm going to show you how to do subnetting or variable length subnet mask VLSM. I'm disappointed that the testout.com video and illustration in the section 5.1.5, 5.1.6 and 5.1.7 did not show you how to determine the subnet when given an IP address and a cited notation. So I decided to create this video and be more specific, or show you in great detail how to find those information. Okay, so let's begin. VLSM or subnetting is a method used to divide a single network, specifically a set of large IP address, into two or more smaller subnetwork, or we call it subnet, or sometimes call it network. So the term subnet and network are interchangeable. Assume that we are given an IP address of 192.168.10.30 with a /28 cited notation. We need to find the subnet that the above IP address belongs to. We need to find out how many subnets are available, and we also need to find out the host IP address available for each subnet, meaning that these IP are those IP addresses that we can use to assign to a device network, okay, in that subnet. So let's begin. First thing, we need to write down the cited notation into binary mask and convert the octet that changes into decimal value. Then that will determine our subnet mask. So /28, we need to write down 28 1 bit. Okay, it's right here. Notice that the first octet has 8 bit, second octet has 8 bit, make it 16, third octet make it 24, and we simply add 4 more to it, make it 28, and then fill the rest with 0. So when we convert these right here into binary, to decimal, we get 240. Now hopefully by now you know that the 8 bit of 1 is equal to 255. Okay, so that is our subnet mask right here. Assuming that you don't know how to do the conversion, you can use my little bit table that I create right here. What I did, I create 8 boxes, and the first box is number 1, number 2, and double of 2 is 4, double of 4 is 8, double 8 16, double 16 32, until you get all the way to 128. Then you simply place the mask or that binary number underneath the table. In this case, notice that 40 and 41 is right here. Okay, and I simply add those those number that are associated with number 1. For the 0, I don't worry about it, but anywhere that I see a 1, I need to add those number. So in this case, I add all of this across, and we get 240, and that's what that is. Alright, so next thing, now we want to find out which subnet that the IP address belongs to. In other words, we want to find out the subnet of this IP address. Well, we simply write down the subnet mask into binary number. We convert the IP address into a binary number. Then we use the AND logic function to determine the subnet. So the AND logic function say anywhere we see 1 1 is 1, 1 1 is 1, 1 0 0, 1 0 0, 1 1 is 1, and 0 1 0, 0 1 0, 0 0 0. So that's a result right here. We convert that back into decimal, and that is the subnet. Okay, so this IP address right here belongs to this subnet. Now the next thing, we need to find how many subnet this given IP address has, and also the available IP address hosts. Well, the formula for number of subnet is 2 to the n, where n is the number bit 1 in the octet that's changing. So in this case, the number of 1 bit in the octet that's changing is right here. So how many number 1 bits right here? 4. So the subnet is 2 to the n, which is equal to 16. So this given IP address right here will have total of 16 subnet. Okay, and the available host IP is 2 to the h minus 2. Please know this formula by heart. 2 to the h. What is h? H is the number of bit 0 of the host portion. The host portions right here, then they are 4 zeros, so h equal to 4. So 2 to the 4 minus 2 equal to 14 IP address available for each subnet. Now if you want to know the second subnet, then how do we find it? Well, we know that the first subnet always begins with 0. So we need to find out the magic number. The magic number is the first borrowed bit 1 from the right in the octet that's changing. Well, these are the borrowed bit 1, 1, 1, 1, because for the default all of these are 0. Okay, for the default class C. So these are the borrowed bit 1. So the magic number is the place value of the first bit on the octet that's changing from the right to the left. So this is the first bit that's but first 1 bit. So the place value of that is 16. So our magic number is 16. Okay, because this one is 1, this 0 is 2, this 0 is 4, this 0 has a place value of 8, and the 1 is 16. So we write out the first subnet, which is always begin with 0, and we add the magic number to the first subnet. In this case, the fourth octet is the one that's changing. So we add 16 to this to get 192.168.10.16. We add 16 to the second subnet to get 32, and we keep on continuing until we get as close as possible, but do not go over the number 255, because 255 is the maximum valid number for an IP address. So when I get to this right here, 240, if I add 16 to this, I will get 256, which is exceed the 255. So I stop right here. Now I write down the subnet. This is the first subnet. How do I know that it's end up 15? Well, number 1, it said it has a total of 14 available IP address. So start with 1 to 14, that's 14. So the next one should be 15. Okay, in a network or in a subnet, the first IP address always reserved for the network ID. Alright, okay, and the last IP address right here always reserved for the broadcast ID. Again, the first IP address of a network or of a subnet always reserved for the network ID, and the last IP address of a subnet always reserved for the broadcast ID. So if I look at the first subnet, it's right here. I write the second subnet. So the last IP address of the first subnet should be 1 number less than the first IP address of the second subnet, which is 15. Okay, so the third subnet is right here. So the last IP address of the second subnet should be 1 number less than 32, and that's how I write out my subnet. Okay. Alright, to answer to the earlier question, what is the subnet that the above IP address belong to? Well, it belongs to this subnet right here. Okay, right there, because the IP address that given to us is right here. So it belongs to this subnet. What is the magic number? 16. Okay, how many hosts available IP address? Well, there are 14. Okay, and how many subnet? There are a total of 16 subnet. Okay, let's look at an example of your 5.15 section in the test out. All right, it gives us an IP address of 10.0.0.0/10 and the subnet mask 255.192.0. So from here we need to determine how many subnet are there. Well, first of all, we write down that /10 into binary number, okay, and these right here are the 1 bit, okay, 10 1 bit, okay, and fill in the rest with 0. So in this case, the number of subnet is 2 to the n. Well, what is n? N is these two numbers right here. So n is 2 because it has 2 1 bit. So 2 to the second power is 4 subnet. Okay, a total of 4 subnet. Now, how do we find the subnet? Well, the first subnet always begin with 0. Okay, so in this case, what octet it changes? The second octet. So we need to find out the magic number and add to this first subnet to get the second subnet. What is the magic number? Well, the magic number is the place value of the first bit, okay, on the octet that's changing from the right to the left. So this is our first bit. The place value of that 64. So our magic number is 64. So when we write out the first subnet, we simply add 64 to the octet that's changing. Again, the octet is changing is second octet. So we get 10.64.0.0. The third subnet, we simply add 64 to that to get 128. And add 64 to 128, we get 192. If we add 64 to 192, it gets 256. It exceeds the 255 number. So we stop right here. Now, if we want to know how many available IP, well, it's 2 to the h minus 2. Okay, 2 to the h minus 2. All right, that's our formula. Okay, all right. So what we need to do is 2 to the h minus 2. There you go. All right. So what is h? H in this case is 22 because you count this 0 right here. They are 22 0. So the total IP available for us to assign to network device or host is 4,194,302 IP addresses. So when you write down the subnet, you start with the subnet right here. You begin with the one number larger than the network ID, and then write down the n IP address of that subnet. Well, how do I know that this is the last available IP address for this subnet? In other words, this subnet beginning with 10.0.0.0 or ending with 10.63.255.255. Well, how do I know that? Well, because I look at the second subnet, it start at 10.64.0.0. So my largest third octet number should be one less than this right here, which is 63. Now, how about 255, 255? Where did I get it from? Well, let's look at this my little bit. Okay, example below. Now suppose that this is some sort of rolling. Alright, let me go back, and I think I messed it up. Let's go back again. Here you go. Alright, now this one's 10.0 and this one's .0. Alright, .0. Assuming that this is some sort of rolling number roller, okay, number roller, I guess you call it. Anyway, for the first IP address right here, second IP address will be .1. Okay, first second IP address .1, third IP address .2, .3. Keep on going until you get 255. Then it start to increment these numbers right here, 1, and it start with 0, and then start with 1 and start with 2, start with 3, all the way to 255. Then it increases to 2. Then it starts this one with 0 and start with 1, start with 2, and then all the way to 255. Then it increases to 3, and keep on doing like that until you get to 255. Then the next value, which is right here, will increase to 1, and then start this one with 0 and start this one with 0, okay, and then 1, and keep on until this one gets to 255, this one gets to 255, then increase this right here to 2, and they keep on doing that until all the way to 63. Then that's end of it, because next number is 64, which is my second subnet. So the last IP address for this subnet is this right here, which is right there, and it's the same thing true for each one of these subnet. Okay, alright, so the last IP address for that subnet is right here. Okay, now let's look at your lab. That's 5.1.7. I believe it asks you to, here you go, it said that it said that you need to, it give you this IP address right here, 192.168.0.0, and you need to find or use the last valid addresses on the subnet to assign to the Ethernet. And for this IP address right here, you need to assign the last valid address to the Ethernet too. So how do we find the last valid address? Well, let's look at this right here. Okay, this one of the given address right there, and the other one. Alright, so we need to write this out. What is the cited notation? /24. So I write down 24 1 bit right here, and I fill the rest with 0. In this case, it is a class C default subnet mask. Okay, so we know that it's only have one subnet, but just in the case, we use our formula. Our formula said the number of subnet is 2 to the n. What is n? Well, there's no n in here at all. There's no borrow bit, so n is 0. 2 to the 0 power is 1, so it's correct. Only one subnet. How about the available host IP? Well, it's 2 to the h. What is h? H is 8, so 2 to the 8 is equal to, and minus 2 by the way, is equal to 254. So they are a total of 254 valid IP address. And the lab said that we need to assign the last IP address to that network called 1. Well, what is the last IP address? Well, this is the last IP address of the network. However, the available IP address that we can use to assign to a host or a network device is 4, because this IP address is reserved for what? The broadcast ID. So the next lower IP address is the one that last IP address available for us to use, which is 254. Okay, alright, let's look at the second one. It gives me us an IP address of 10.0.0.0 with the cited notation of /16. So we write out the 16 1 bit, okay, and we convert that into decimal. So we know that the subnet mask is right here. This is a class B default subnet mask. Alright, we want to find out that how many subnet. Well, again, this is a default, so we know that's only one subnet, which is 2 to the n. So it tells us that, so which is good. But now we need to find out the last valid IP address that we can assign to our NIC card number 2. Well, notice that this subnet is started from here and it ends with the last IP address right here. How do I know it's 255.255? Because these two octet right here are the one that's changing, and the maximum value of the third octet is 255, and the last octet also has a maximum up to 55, so that is the last IP address. So that of that subnet, so the last IP address available, again the valid host IP address is 10.0.255.254, because this is the last IP address, but this one is reserved for the broadcast ID, so it's one number lower than this right here, which is there. Okay, so that's how you get the valid IP address. Thank you.